So a good question is, why can the second derivative test fail? Recall, the first derivative test cannot fail. The second derivative test can. A couple of examples here. Let's look at f of x equals x cubed, and f of x, the second function should be g of x, equal x to the fourth. For f of x equals x cubed, case 1, what's f prime of x? Well, that's 3x squared. And the second derivative is 6x. Quick sketches of all three functions. And this should be pretty flat right there. F prime, and f double prime. So again, I come back to this comment here. First derivative test cannot fail. The critical point is where this function either hits 0 or doesn't exist. The critical point, therefore, is right here, at x equals 0. But if you notice, a little bit to the left of 0, f prime of x is greater than 0. A little bit to the right of x equals 0, f prime of x is greater than 0. So f prime of 0 equals 0 implies critical point is the set 0. So the first derivative test gives you no information. If the first derivative test gives you information, it's not an extreme point. This graph goes up before 0, goes up after 0. Even though the second derivative was 0, and then this is why it fails, because f double prime of 0 equals 0, and therefore second derivative test fails. F has no local / relative extrema. Now be clear, I am not saying that if the second derivative is 0, it's not an extreme value. I've only done one of the two cases. I come back and start this all over again with the second function I mentioned, g of x. So case 2, g of x equals x to the fourth, g prime of x equals 4x cubed, g double prime of x equals 12x squared. Again, graphing the three functions. G now looks like this. G prime now looks like that. And g double prime looks something like that. Again, forgiving my bad drawing abilities. Again, looking at the first derivative, finds the critical points where this hits the axis or doesn't exist is right there. The critical point is the only value I hit the 0 at, which is at x equals 0. But notice over here that g prime of x is less than 0, but over here g prime of x is greater than 0, which means that g was going down, then up. So the first derivative test, looking at looking at g prime, down to up means we have what here? Well, we have as you can look at the picture here and see, a minimum. Therefore, first derivative test says local relative minimum at x equals 0. Second derivative test, though, point here, unfortunately, since g del prime of 0 equals 0, second derivative test fails. Even though g has an extrema. Again, we're still talking local or relative here. So this illustrates that if the second derivative test gives you a 0 value at a critical point, in the case of f of x, we had no extrema. In the case of g of x, we did. So this does not tell you that it's not an extrema. It still might be. The second derivative test cannot tell you. Notice in both cases of the first derivative test did give us the information we wanted. In this case, the first derivative did change signs. The part that is often left out in the first derivative test is that if the derivative does not change signs, it's not an extreme value. But that's also equally true. So again, with the f of x equals x cubed, it was positive before, positive after, and therefore not an extreme value.